All right. Welcome, everyone. Just take a second here to get set up. All right, I think we're good. So welcome, everybody, to sort of an extra stream that we're doing today. I had a little bit of time to go ahead and do another stream today, and I left off on the last one in a place where I wasn't really happy with it because I kind of ran into an issue at the very end of the stream there and couldn't figure it out before I ran out of time. So I figured I'd do another one today and make a little bit more progress on the hot reloading for our libraries. So with that, before we jump into things, just a couple of quick items to go over. So first and foremost, I wanted to announce that I am officially a Twitch. I got the Twitch. What's the word I'm looking for? Affiliate. So what that means is basically that subscriptions are now available. So we also have emotes available, custom emotes available, and we also have a number of things that you can use channel points on. So all of that is available now. And I wanted to just very quickly say thank you to everybody who has followed me thus far to help me get to that point, because obviously none of this is possible without you guys. So I wanted to go ahead and bring that up, and thank you guys very much for that. I also realized that I had follower-only chat on, and I've turned that off, so anybody that is looking at the stream now should be able to go ahead and chat. So with that said, this is meant to be an interactive stream, so if you guys have questions along the way, feel free to pop them in the chat, and I will keep an eye on that, and every once in a while I'll go through that and respond to it. So okay, so that is pretty much everything that I had in mind. So let's go ahead and jump back into this. So last time we were actually running into an issue where I'll go ahead and just do a quick build. Where we were basically crashing because we were addressing some memory that hadn't been allocated or something along those lines, and I wasn't sure what the heck was going on. And of course, 2 minutes after I shut down the stream, I actually figured out what it was because it dawned on me. But to serve as a reminder of where we were, so I could basically, when I run the application, we get this unhandled exception that we're trying to read some memory that we obviously should not be reading. And what should have given it away is kind of where it is. But it's an issue specifically with our render view skybox. And this is actually something that somebody had brought up on the YouTube channel a while back. I guess it's probably about 2 weeks ago now. That I've been meaning to fix, but just never got around to. And it finally came back and bit me in the ass. So what the issue is here in our game C, in the middle of our render, we are sort of creating this skybox packet data to be rendered later on. Now, the way that this works is the render function is responsible for building up all this packet data, and then that gets handed over, and then the engine then takes all that packet data and uses that to send off to the renderer to render everything. And the issue here is that we're using a local variable, which I don't know how this ever worked before. It definitely should not have. This should have reared its ugly head before, but for some reason, removing the static data exposed this issue. So basically, long and short of it is this is going out of scope. And because of that, when we actually go to use the data that we're passing in here, it's obviously not available anymore because it's out of scope. So with that, it's just a simple quick fix within our build packet. So if we go to render view skybox, basically within the build packet, we are taking the skybox data that is passed in here. So if we look at the build packet, we're creating this local variable. and then setting the skybox in it, and then we're passing the address of that local variable, right? So it's a pointer on this side, and we're basically just taking that and setting it down here in our extended data. And this is bad. This is basically where we're going wrong, because after that function exits, that goes out of scope, and what this is pointing to no longer exists. Now again, as to why that worked in the first place, no idea. But we're going to go ahead and fix that now. So what we're going to do is instead take a copy of that data, and we're going to allocate a new pointer to hold this data. And you might be asking, hey, allocating something every single frame, that's kind of slow, isn't it? And yes, ordinarily it would be, except for the fact that we have a frame allocator, which is designed exactly for this type of thing. So our linear allocator is super fast because it just literally allocates in a linear fashion, and we don't have to worry about freeing. We don't have to worry about maintaining any sort of free list or anything, that kind of thing. And so what we can do is we can just very quickly grab a pointer to some memory, and at the end of the frame, it all gets wiped out and then reset anyways. So we're not going to be leaking memory doing this because of the way that our frame allocator is set up. So this is a good chance for us to go ahead and use that. Before we can do that, though, I don't believe we have that included in here. We do not. So that will need to be included. So that's under memory, linear allocator. All right. And down here, instead of doing this, I'll just comment that out for now. We are going to say out packet extended data is equal to linear allocator allocate. We are going to pass the frame allocator, which I believe is already a pointer to that. Yes, it is. And then for the size, we're going to say size of, and skybox packet data, right? And that's going to give us a block of memory to copy into. And then all we do is basically just, take a copy of everything that is in that memory. And yes, it does involve a copy operation, but in this case, I don't think that's going to be our performance bottleneck for sure. So at this point, I can do a k copy memory. Our destination is going to be the out packet extended data. The source is going to be our skybox data. And obviously we want the size of our packet data right there. And that will be sufficient for our purposes. Now, again, since this is a linear allocator, I don't need to worry about destroying this because this just gets reset on every single frame. So we can go ahead and just use this as is. And once that's finished doing its thing, we will run. And what do you know? We are ready to go. We're fixed, right? So that gets us back to a running state. And so I'm going to go ahead actually and merge this code in right now into the repo on the main branch, so that there's a quick and easily accessible working version of this before we actually move on to the next set of changes that we're going to make, because I don't know if we're actually going to complete this today or not, so we'll see. So I believe I'm already on the feature branch. Yes, I am. So I'll go ahead and just add this real quick. Push that up. Fixed local variable scoping issue. All right. And let me go ahead to the repo here. And I'll show you guys once more how we do this, just as a reminder of how this kind of stuff works. So I've just pushed to this branch here. So we'll just do a comparison and open up a pull request. So this essentially just contains all the changes that we've made thus far. So a lot of this is the renderer types, the front end, all these changes we've made so far. with all of the interface changes and all of that, right? So that's all that stuff we covered last stream. And we are able to merge. So we'll go ahead and create the pull request. And the reason I'm doing this as a pull request is because we can actually squash and merge this into a single commit. So it's a little bit easier for you guys to follow. So we'll go ahead and squash and merge that. Don't need all that stuff. We can just get that in there and delete the branch. All right. Ick Pablo, thank you for the follow. I appreciate that. All right. So that is that. So at this point, all we need to do is just kind of continue on our dynamic loading, right? So before we can tackle hot reloading, we actually have to load things dynamically. So there are two things we're going to load dynamically. We are going to load our Vulkan renderer plugin, and then we are going to load our game code dynamically. So we're gonna do that with both those things. Let me catch up here with chat. Vanoma, did you fix the issue from last stream? Yes, that is what the issue was that I just fixed. So I don't know if you were here when I did that, but basically the issue was this local variable being created here in the skybox packet data. So we were creating the variable here. You came 2 minutes ago. Okay, so I'll go over it again real quick. So the we were creating a local variable here for skybox data, and we were passing the address of that data here. And then in the view itself, we were basically just assigning that as is here, right? So we have a pointer to the data here. We were just assigning that. The problem is this was going out of scope, right? Because we build our packet information here, but the engine then later hands that off to be rendered. So this was going out of scope. So what we do is we use our frame allocator to allocate some memory on the heap for this particular frame, and then we just take a copy of that data instead of direct assigning it, and then we no longer have to worry about scoping. Okay, David, hey, I'm so happy I can participate live for once. I'm based in the Netherlands, and time zone is not always in my favor. Yeah, I could totally understand that. The Netherlands, that's the land of my people as well. Hence my last name is Dutch, so how's it going? Cool. Well, thanks for tuning in for sure. All right, so that is basically that issue. So what we're going to do today is focus on the actual dynamic loading of this library, and if we have time, we're also going to load our game code into a separate library and dynamically load that as well. So as a quick refresher, we have in our entry.c, we're sort of doing this hard-coded Vulkan renderer plugin create thing, and this sets up all of our function pointers and all of this stuff. So this was sort of an intermediate step that we had to take to get to where we need to get. So what this means is that we have to include the Vulkan renderer plugin within the game itself, which means that we also have to sort of hard link that DLL within our game as well, which is not ideal in terms of trying to be dynamic about stuff. And so instead of doing it this way, we're actually going to set something up where we can load a DLL. I say DLL because we're on Windows, where we can load a DLL dynamically and obtain a function pointer from that DLL once we've loaded it. So the first parts of this are actually going to be represented in the platform Win32 level. And again, probably what I'm going to wind up doing with this is similar to how I handled some of the Vulkan platform code. Because my Windows machine is the only one that's really set up for streaming at the moment, I'm probably going to implement the other platforms off camera and then just go over them in the next stream whenever we actually set that stuff up. But for now, we basically need three different main functions when it comes to loading a library. We need to actually load up the library itself, or the code library itself. So we need a method for that. Since we're loading it, we also need a method to unload it. And then we need a method to reach into that and say, hey, give me a function called this, and return to me where that is in memory so that I can call it. And so those are what we're going to implement now. So the first thing we're going to do is the load. So I'm going to have this be a return type of B8 to indicate success or failure, because that's always a good thing to know. And then we'll call this, I guess we'll call this platform, if I can spell, load library. Yeah, I think that'll work for now. It's going to take a const char, we'll just call it name. And then we're also going to basically write out to some structure. So let's go ahead and call this dynamic library. We haven't defined that yet, but we're basically going to take a pointer to that, and we're going to call it out library. Right. So with that, we need to go ahead and define this dynamic library. And I guess probably, do I want to do this in platform H? Yeah, it's as good a place as any, I suppose. So we'll type def a structure. God, I can't type today. Dynamic library. And within that, we are going to define two things. We're going to need a U64 and then internal data size, right? And then a void pointer to hold our internal data. Now, why are we using a void pointer and why are we using this size, right? Why don't we use actual types? Well, that is because each individual platform has its own definition of what a library is and has its own different definitions of those types. And so what we're going to do is we are going to keep it this way so that it's completely transparent outside the platform layer as to what those types are. And we're not going to have to worry about any of that stuff external to this. And then internal within our libraries, we'll go ahead and just cold cast to whatever the actual underlying types are that we need. Let me go ahead and just close some of these other things here because we have a lot of files open and that's kind of dumb. So we have a lot of stuff open we really don't need to have open. Yeah, don't save that, that's fine. Wow, a lot of stuff. Okay, I probably should just close them all and reopen, I suppose, but that might help things go a little faster if we get rid of some of these. All right. Oops. Okay, there we go. All right. So back in here, the first thing we're obviously going to have to do is do a sanity check. So if we don't have a name, or we don't have a pointer to the out library, then obviously we can't do anything, right? So we'll just return false there. That is a failure. We'll also do a return true down here just to kind of get that stubbed out. And the function that we're going to wind up using is a Windows-specific function in this case. Let me open a new window here, new browser window. So we are going to use something called load library. And I might have to say Win32, I'm not sure. Load library A. So there's two versions of this. There's like a version and a W version, which really doesn't matter to us. So I'm probably just going to use load library A. But basically, what it does is you pass it a string as to what the file name is, and then it returns to you a H module, which is sort of Windows's representation of the library that we load. Now there is a load library EX function that provides a little bit more a little bit more flexibility and options as to how we actually load this thing up. But in this case, I don't think we actually need that. So the important thing to note is the return value here. So if the function succeeds, the return value is a handle to the module. If the function fails, the return value is null. So we need to check that for our success. Okay. So we will say here, let's say H module. We'll use the Windows type since we're in the Windows platform. And we'll call this library. I guess that's fine. And then we'll say equals load library A. And then this type here is a long pointer to a C string, which basically just means that we can pass name directly. Okay. And at this point, we should have loaded up the library. So obviously we'll need to say if the library failed to load, return false, right? Because we don't want to continue if that has failed. All right. The next thing is we need to actually fill out our out library. So what we'll do here is we'll say out library internal data size equals size of. And then in this case, it's an H module, right? And then the out library internal data size is just, oops, not size, just the internal data itself is going to be equal to library. If I can type. All right. And that's it, right? Because this already gives us a pointer. If we examine this type here, this is an H instance, which if we take a look at what an H instance is, the underlying type of that is a pointer, right? So all we have to do is just do a direct assignment here. And the only reason we're keeping the size really is for convenience sake. We don't have to keep the size. But I like to do that just in case we ever need to know about that. For some reason, we have it, we might as well just use it. All right. So I suppose one other thing we could do is just to be sort of on the safe side here is we could zero out the out library before we actually do anything else, right? So if we don't fail out at this point, in fact, let me be a little bit more explicit here. So let me separate these out, and I have a reason for doing this. So if we don't have a name, obviously we're not going to be able to do anything. And that is, actually, let me do out library first. Okay. So if we don't have an out library, then there's absolutely nothing we can do. So we're just going to return false straight away. Otherwise, we do have a out library, so we should go ahead and k0 memory. So out library. And this is just to sort of make sure that it's super obvious that we have nothing here, right? So we'll say size of dynamic library. Okay. That way, if we fail anywhere else in the line, we know that everything within this is zeroed out. It just makes things a little bit more obvious. All right. And so that is all there is to loading a library at this level. However, we want to make this a little bit more generic because for Windows, for example, the file extension is DLL. For Mac OS, that might be .dylib, or for Linux, it could be like .a or something. So what we're going to do is we're also going to make this generic in such a way where we only actually pass the name of the library that we want to load, not the entire file path. And we'll take that and translate it into the platform-specific extension and all of that we would need. So what I will do is, instead of using the name directly here, I will take this one step further and we'll create a character array. And I think there is a max path variable. which in this case is 260 characters. That should be more than enough. And we will call that file name, right? And we're going to, we're basically going to use a string. I don't have my string library imported, so let me do that. So we'll include core k-string. We'll do a string format. And the destination is going to be file name. The format string itself is basically going to be just a string, right? And then .dll. And the string that we pass in is the name, right? And basically, this will give us our file name, our nicely formatted file name, which we can then pass here. So when we actually call this platform load library, we don't have to worry about what platform we're on, trying to detect that at the engine level or any of that stuff. We can just pass the name of a file that it should expect, and we should be able to load that as is, okay? All right. So I guess one other thing that we should probably do is we have this dynamic library structure where we hold the data itself, but we actually don't have any way to identify what this is. So if we have multiples of these loaded up, it might be nice just for even debug purposes maybe to actually just have a name in here, right? So we can at least see what the heck we're loading. So after we get to here, we'll go ahead and do a, we'll say out library name equals string duplicate. And then we will just pass it the name, okay? With that also, if we're thinking about hot reloading, one of the things that we're going to need to know is what file are we going to hot reload, for example? What's the file name that we need to be watching, etc. And so what we can actually do is add one more property here, and we'll say const character file name, right? And we'll keep a copy of that as well. And so, whoops, close that. So we can also just come down here after we've created our file name and say out library file name equals string duplicate file name. All right. And now that just makes it a little bit more obvious when we're stepping through our code what the heck is going on. All right. So that is the loading. The unloading, we'll also go ahead and return a B8. There's not really anything we can do if an unload fails. I don't even know that we should explicitly care about that, but I'll go ahead and return a failure result if for some reason that does fail. And to stick with our naming convention, we'll say platform unload library. So platform unload library. And come to think of it, you know what? This should probably be named a little bit differently. We should probably call this platform dynamic library load, right? Because our sort of naming convention has always been, you know, verb at the end. So let's go ahead and just do that here and just call that unload. And then again, we'll just take the const character name, right? We only want to deal with names here, not file extensions. And we also need the dynamic library. We need a pointer to that. We'll just call that library this time. All right, and then we'll basically just wind up doing a recheck of this minus the 0 memory, right? So obviously if we don't have a library, there's nothing we can do. If we don't have a name, there's nothing we can do. In this case, I think we can just go ahead and leave them combined. So I will do that just to simplify that a little bit. And then let's go ahead and have a look at, I believe it's is it unload library or free library? I can't remember. Is it down here? Free library. So free library does not, oddly enough, have an A or a W, probably because it doesn't take in a string, it takes a already loaded module. In fact, that's going to be exactly why. So this is what we're going to use to unload the library. So in this case, if the function succeeds, the return value is non-zero. If the function fails, the return value is 0. And then to get extended information, call get last error. Okay, so in this case, we'll go ahead and get the H module. We'll call this internal module equals library internal data, right? And we'll just cold cast that to H module to give us what we need. And obviously we should probably do a sanity check on this, right? So if not internal module, return false, right? Because obviously there's nothing we need to do there. Otherwise, we will go ahead and call free library, and we will pass through the internal module. Right? And we'll use the Windows type of bool here, call it result. And what was that? It said, I think it said non-zero is success and 0 is a failure. So we'll say if result equals 0, return false. Otherwise, we'll return true, right? However, before we do any of that stuff, we need to perform some cleanup because we did some dynamic allocation up here. So if you recall, the string duplicate actually does allocate some memory. So we need to go ahead and clean that up as well. So I think we had a string free here that we can use. Yeah. So we should be able to use this string free, and that's actually what I'm going to try doing this time around. So string free, and then library name. We should always probably check to make sure that exists. So if library name, right? And then we'll do the same for file name. All right. And then we should probably also just zero those things out just to be explicit. So we'll just do that. All right. So in this case, after we've freed the library, we'll go ahead and also explicitly set the internal data to 0 and the internal data size to 0. We could zero out the memory, I suppose. In fact, yeah, it's probably less error prone. Let's just go ahead and do that. Instead of setting these here, let's just zero out the whole thing. So we'll say library and then size of dynamic library. All right. Okay, so that should clean up the library and all of its resources, at least as far as we've gone this far, right? So we're now able to load up a library and unload a library, but that doesn't do us a whole heck of a lot of good if we don't actually have pointers to the functions within that library to actually work with. So that is going to be the next thing that we have to do. So I think probably the best way to handle this is I'm actually going to jam this into another struct that we're going to kind of keep within this dynamic library. So I'm going to call this typedef struct, and I'm going to call it dynamic library function for now. I may wind up renaming that if I can think of a better name. If one of you guys think of a better name for that, feel free to dump it in the chat there. Once again, I'm going to go ahead and keep a name, okay? Because that'll make it a little bit easier to visualize exactly what we're doing. But also, we're going to need that for our hot reloading as well. So we need basically a name and a memory address, which we can hold, and a void pointer. So I'll just call this PFN for the function pointer, right? And then what we're going to do in the dynamic library is we are going to make an array of these things, just called functions. And we're going to use the D array for this. That way we can sort of load and unload functions as we need them. I don't think we really need to unload a function pointer on second thought, but we can sort of add them ad hoc anywhere in our code as we want. We don't really want to sort of lock down the end user on how they use this code. So with that, let's go ahead and implement this. So do we have darray in here? We do not, so I'll need that. So we'll include containers, darray.h. All right. And then down here, we're going to implement yet another dynamic library platform function. So I'm just going to copy pasta the first part of that. We are going to use a Boolean result here too, because it's possible that the user passes us junk data. Do I not know what a schedule is? Well, no. The reason that I don't have a specific schedule is because sometimes things are a little bit too hectic. I have a lot of things going on right now. It's not always possible for me to schedule stuff. So my only schedule that I have is on Wednesday nights. And then anywhere that I can pop in an additional stream, I go ahead and do that in between. Can you please explain the idea behind linear and dynamic allocator? Yes, I can. Okay, so basically the idea here is our dynamic allocator works the closest to your typical memory allocation pattern, where you might call malloc, and then it just returns a memory address from you, or to you rather, at a given size. And then what you do at that point is whenever you need to free it, you just call free and you pass back just that pointer, and it knows internally where that pointer is and how to free that memory internally. And so our dynamic allocator mirrors that, but it works out of a pool of pre-allocated memory. So what that gives us is we don't have to reach out to the OS to allocate memory every single time we allocate. We can just pull from that pool of already allocated memory. And so the way the dynamic allocator does this is it maintains an internal free list of basically unallocated blocks of memory. And then as we sort of pull out of that, there are entries that are kept that allow us to free and add back to that free list, right? Whereas the linear allocator is much more of a dumb allocator. So it literally allocates in a linear pattern. So you start at 0 within a arena of memory, and every time you allocate, it just kind of keeps moving a pointer forward. And the benefit of that is there's zero overhead with it whatsoever. There's no free list to maintain. There's no free logic to worry about, because you can't really free from a linear allocator, right? It just allocates and that's it. And so linear allocators tend to be very fast, but it also means that once you've allocated from a linear allocator, the only real free is to free everything. And so they have different types of uses. Your dynamic allocator is more your general purpose allocator, whereas your linear allocator is used for anything that needs to happen really fast, but you don't care about the stuff necessarily being freed until it can all be freed at once. So 2 examples of where we're using this is our systems allocator, where we initially stand up all of our various systems within the engine. We use a linear allocator for that, because we don't need to worry about freeing any of that stuff until all the way at the very end when we actually shut the engine down. So That's one example. And then the second and probably the best example of it is we have something called a frame allocator, where we have an arena of memory that's used every frame that we can pull from to perform any dynamic allocations that we need for that particular frame. And because linear allocators are so fast, because there's basically zero overhead with them as far as allocating, we can do that every frame, and it's much faster than actually having to call malloc or using our dynamic allocator, which has to manage the free list and all of that. So the way that the frame allocator works is it's just a linear allocator that's reset at the beginning of every frame, and we can just pull out of that as we need it, and then all of that memory is used for that particular frame, and then once that frame is done and we move on to the next frame, it's wiped out and it can be used again. So that is pretty much that. Looks like my Discord is not on streaming mode here. Give me 1 second so you guys don't have to hear my Discord pop, because that's kind of annoying. I don't know why that's not turning on automatically, but anyway. So I hope that answers your question. Can't forget the stack allocator. Yeah, so a stack allocator is actually something we're going to implement at some point. I just haven't yet, but that actually is something we're going to be adding. Big thank you. Yeah, no problem. Came here to bug you, and now that I'm done, I'll be going and doing my own thing. That's cool, man. Thanks for popping into the stream. I appreciate it. Appreciate the support. Okay, so we were going to implement something here to load our functions dynamically. So we have platform dynamic library. I guess I could say load function. I'm not sold on that, but that's what I'm going to go with right now. So we'll have a constant character array, obviously, for name. That's going to be the function name. And then we're going to take in our dynamic library, right? And we're going to say this is the library that we want to load the function for. And obviously, we need our return true here. I'm going to copy pasta this up here. All right. And we'll actually have to do a few other checks. So just because we have the name and the library doesn't necessarily mean that we have everything we need. We also need to check the library internal data exists. So if that does not exist, we're also going to return false. Okay. All right. So there is one more thing that we're going to have to add. So just to kind of circle back, we have this D array here of functions that we're going to add to. We haven't actually set that up yet. So in our load function, right before we go ahead and return true, once we've successfully done basically everything else, we're going to do out library functions equals D array create, and that's going to be dynamic library function. Okay, so that we have that array. Obviously, that means that our teardown is going to have to undo that. So let's go ahead and undo that before we actually do this, just so we don't actually forget it. So that is going to be right before we zero out the memory. So we'll say if library functions, right? And then we'll go ahead and say u32 count equals d array length library functions. So we'll get a count out of that dynamic array. And then we'll just do a for loop, which is, u32 equals, u32I equals 0. I is less than count plus plus I, right? And then we'll go through, and this kind of seems like overkill, but I'm going to do it anyways, just to make sure that we're not running into runtime errors or something like that. I'll go ahead and say if, actually before I do that, I will say dynamic library function will take a pointer called f to the address of library functions sub I, right? And then here we can say if not f pfn, right? So if the pfn doesn't exist, we don't have a function pointer for some reason, we don't really want to do anything, right? So we're just going to skip that one if it doesn't exist, if there's nothing actually to free, okay? And then let's see, is there a, I don't recall if there is a way to actually unload. So before we go any further, let's actually, let's talk about the next one that we're going to look at, which is get proc address. So this is the next Windows API function we're going to use. So get proc address retrieves the address of an exported function, also known as procedure, or variable from the specified dynamic link library. So it takes an H module, which is our library, and then a name. It returns a varproc, which is a handle. Wait a minute. Here we go. So this is the address of the exported function or variable. If it fails, it'll return null. But there's no way to actually, there's nothing here to actually free, right? Because it's technically part of the loaded library. So we don't need to do anything here except for the name, actually. We don't even need to look at the pointer function, right? All we really care about is the name. Because the PFN is just a pointer in memory of the loaded library, which will go away when we unload the library. So actually, the only thing we need to look at is the name. So instead of continuing like this, I'm going to instead string free f name, right? That will make sure we don't leak any memory when we are unloading. And I guess we can go ahead and clear out or kill the array too. We may or may not, we may want to actually have a Boolean later on that either does that or doesn't. But for now, I'm just going to go ahead and kill it. So I'm going to say darray destroy library functions. And library functions will obviously be 0. Not 100% sure that's the way I'm going to go, because like, do we want to recreate this every single time we reload? I don't know. I don't think so. But then again, it's not like it's going to be something we're doing like every single frame, so I don't know if it really matters all that much. The other thing that I'm thinking is there may be portions of this, like this section of it, for example, that are a little bit more agnostic as to what exactly is going on the platform layer. So we may wind up making some of this generic and like pulling it out to sort of a generic platform layer, which is actually something we need to address at some point. Anyway, I'm not going to do that now. This should be sufficient to keep us from leaking memory. All right, so back to the topic at hand of actually loading the proc address or the function address. So what we're going to do here is create a dynamic library function. We'll just call this f, right? And we're going to set it to just 0 initialized, right? Nothing fancy. Then we will go ahead and say get proc address. We are going to use the library internal data cast to a H module, right? And the proc name is just going to be name, right? And this, is just the function name, so we don't have to worry about, any string formatting. It is case sensitive, obviously, but we don't have to worry about anything as far as that goes. So this returns a varproc. So we'll go ahead and say f address equals that, okay? If we examine this type, I think it is just Yeah, it's an integer pointer, right? So all we really need to do is we could just use that to say f.pfn equals f address, right? And then f.name equals string duplicate, and we'll call name here. We should, however, double check that f address exists. So function address, and then we'll go ahead and you know what? We'll do a negative check here, right? So if that doesn't exist for some reason, we will abort out. If it does exist, then we'll go ahead and fill this out, which actually this declaration can go down here. Okay, and then the next thing we'll do is we will say darray push. The array is going to be library functions, and we are going to push f into that list. And that is how we're going to keep our function pointers. And the advantage of doing this is, since we are keeping the name, when we go through and actually reload the library, all we'll have to do is essentially iterate that list, and it'll automatically reload the functions for us. So it should be pretty straightforward to actually use. But for right now, I'm not going to worry about the reloading. I'm just going to worry about the loading. We'll get that working first, and then we'll circle back to the reloading. So really quickly, I just want to touch on something. If you're new here to the stream, welcome. This is designed to be an interactive stream, so if you do have any questions along the way, feel free to drop them in chat, and I'm keeping an eye on that, and we'll answer as we go through. Okay, so let me go ahead and define all of this stuff on the platform H. So we'll come down here to the bottom, and I've just copied over basically the function signatures. And we need to export these. So obviously we need a KAPI. Let's see, David. I need to go to bed, unfortunately. However, I'll watch the rest tomorrow morning. Thank you a bunch. Love your work. Awesome. Well, thank you for joining and jumping into the chat. I really appreciate it. And hopefully we'll see you on the next stream. Well, maybe not. You're in the Netherlands, so yeah, I guess it is pretty late over there, but we'll see you. Okay. So one thing that I probably should mention that I sort of glossed over in the documentation here is this retrieves the address of an exported function. Exported function is an important thing to not gloss over. So let's talk about that for a second. We have this KAPI here, which for the Windows / MSVC compiler means that we prefix this declspec DLL export. If we don't do this, we cannot use get proc address because it's not considered an exported function, and therefore you cannot load it using the get proc address, right? So it's super important that we do that. Now, we are exporting these platform functions because we want to be able to call them from game code if we want to. So just be aware of any time that we're using any of this stuff, especially with loading up functions, they have to be exported. All right. So I'm just going to jam some comments in here real quick. Loads a dynamic library. The name of the library file, excluding the extension, right? So it should be the file name only. And we want a pointer to hold the loaded library, right? And then it returns true on success otherwise false. And we want to, let's go ahead and just put required in here for both of these, because those are required properties. And since this function signature is largely the same, I'm actually just going to copy pasta this for expediency, and we'll say unloads a dynamic library of the, actually, do we even need, we don't need the name here on second thought. Yeah, because the library already has a name. So we actually don't need this. We can just take the library itself. Right? So we'll simplify our API a little bit here. So we don't need the name. This is just library, not out library at this point. Pointer to the loaded library. True and success, otherwise false. The rest of that is unloads the given dynamic library. Right, that makes more sense. Okay, and then this one here is just loads an exported function of the given name from the provided loaded library, right? The function name to be loaded and the library, actually a pointer to the library to load the function from. And again, true and success, otherwise false. There. What is the difference between static and dynamic linking? So static linking is basically where you take all of the code from the libraries that you're linking, and it essentially gets included into the library that you're compiling. Versus dynamic linking, you can load those libraries dynamically, which is what we're about to actually do. That's sort of an oversimplification of it, but that's basically the difference between it. Is how they're actually how that code is actually represented, right? So if you statically reference a DLL, then you don't then have to also reference that down the line. So in our case, what we're going to do is with a dynamic library, it's going to allow us to load those libraries in such a way where we don't have to hard link them into our code. All we work with is basically just an interface, and from that interface, we're able to call functions and not have to worry about what any of the underlying types or code or any of that is. Hope that makes sense. Okay. All right. So that is that. So the next thing that we're going to do is, now that we have this in place, we need to revisit how our, oops, I want entry C. We need to revisit how our plugin is actually loaded. So what this is doing right now is calling a specific function, because in our setup for our, oops, not the post build. In our setup for our game, which is here our testbed, right? We are actually telling it to link and use the Vulkan renderer, right? So this is what we actually want to get rid of. And in fact, while I'm in here, I'm going to get rid of it now. So we have the engine. So the only thing that we really want to link with right now is the engine. The engine, we're not going to hot reload. That may change in the future, but for right now, we're not going to hot reload it. So instead of linking with the Vulkan renderer library, we're going to load it dynamically. So what this means is that we now can no longer use the files like this. We no longer include those, okay? But instead, what we do is we go ahead and load up the library from here. So instead of calling Vulkan renderer plugin create, we are actually going to load up a library and call that via our new functions that we just put into our platform layer. Before we do that, though, I actually kind of want to go into the plugin itself and rename that function because it sucks. So it's already exported, and this is called Vulkan renderer plugin create. I'm just going to do plugin create and plugin destroy. Right? And this is a much more generic interface for us, right? We can just deal with the I guess I could say renderer plugin create, but I think I'm going to go with plugin create. So the renderer plugin type is in the engine itself. It's not in the Vulkan library. So we should be good to just use that. So I've renamed that there. I'm going to rename this and this. And then we should go back to entry. And instead of calling this directly, for now, we're going to go ahead and include platform, platform.h. And instead of calling this, we will call platform dynamic library load. And if we look at our bin folder, we have Vulkan renderer.dll. And this is the guy that we're going to be loading up. So again, if you recall, we actually remove the requirement to have this DLL extension. So all we're going to do is say Vulkan renderer, right? And we need somewhere to actually store this, right? So we have this dynamic library function. So I'm probably going to, whoops. Let's go ahead and store this in, I guess, our game state for right now. This is very temporary, but let's do dynamic library Vulkan plugin, right? So we'll have that there, which also means I'm going to need to do platform here. Platform H, so that we have that type. Yep, that should be good. So now we can say outgame Vulkan. Oops. Put that in the game state, right? Yeah. I don't know why IntelliSense isn't picking that up yet, but we want to use the Vulkan plugin, and we want to pass the address of that, and then we will check the result of it. So I guess we could do a negative check in the result. Like that. Okay. Application has no field. Oh, because I put it in the game state, not the That's the application, not the game state. I should probably rename that. That's confusing. Let's call that out application. Let's see. I guess. Oh, right. We already have the renderer plugin here. So, yeah. We don't need this in the game state. That's my bad. Let me get rid of this. I was going to say, this seems wrong. Okay. This should be renderer plugin, right? Okay, that's better. So, basically what we're saying here is we are going to, wait a minute. That's not the library, though. That's still not 100% correct. we have the plugin there, but we also need the dynamic library, renderer library. Do we have platform? No, we need platform. Include platform H. Okay, now that should be correct. So we go renderer library, not renderer plugin. Okay, so now this is very generic, right? All we're doing from the entry point here is we're saying, hey, load up something with this name, which this name could be anywhere. We could read that from a text file or what have you. And that is going to be our renderer library. So that's going to be our renderer code, if you will. Obviously, if that fails, return false. If it does not fail, then we next want to call platform dynamic library load function. And in this case, that function is going to be, what did we call that? Plugin create. Right, so we're going to load plugin create, and we just reference it by its name as a string. And obviously we're going to have to pass the library that we're going to load it with it. Again, we'll do a negative check on that to say, hey, if this doesn't load, return false. All right, and so now we'll have a function pointer. So the next thing that we'll have to do is this was actually instantiating that plugin. So now we'll need to go ahead and call this function that we just loaded. So this is a little bit hacky. We should probably come up with a better way of doing this for right now. But the way that I'm going to do this is for u32i equals 0. I is less than, we need to get a count. So u32 count equals d array. Do we not have d array? We don't have d array. Include containers d array. D array length, and we need out application renderer library functions. Okay, so I is less than count, and then plus plus I. Wow, why did that jump there? What is going on with you, VS Code? I wanted that here. Okay. So u32 I equals 0, I is less than count, right? And then we'll just do a dumb string comparison. So we'll need include core k string string equal, and the first string will be plugin create. The second string will be, let's go ahead and get a pointer to this function. So we'll say sub I, we want the address of that, and then dynamic library function, that's a pointer, f equals that, right? So we'll just take this for convenience. That way we can say f name. So we'll compare those two to say, hey, if those two are equal, then, whoops, that's why that was weird. So if those two are equal, then we will go ahead and call the function. So we'll say f pfn, and then from here, we're actually going to have to cast that to a known type here in a second. We are just going to pass the address of our plugin. Okay, and so our f pfn is going to have to be casted to the type of function that our renderer plugin is. So right here in our plugin, this is basically our function type for the create. So I'm going to grab that, and we will use a type def. No, let's just type def that here. There's going to be a better place to do this, but we'll do it here for now. So we just need to basically call this a that should work. Cast it to a pointer function. And then we should be able to call it. Let's see. OutGame is undefined. Oh, right, because we named that out application. Okay. So this looks kind of complicated, but what is going on here is basically we are taking the address of PFN, right, or where that function is. We are casting it to our typedef function pointer, right? And then at this point, we are going ahead and invoking that function pointer and passing it the address of our renderer plugin. And then we're going to need to take that and do a negative check against its result, right? Because that returns a Boolean. And we'll return false if that fails. Okay? And so that should be everything that we need to do to replace this. Now, this is kind of ugly at this point, right? We're going to make this a little bit nicer and a little bit easier to use. But we just need to basically confirm that it's working at this point. So I'm going to do a clean and a build. And it looks like we have a couple of errors here. Oh, the string free. Oh, string free only uses. Oh, that's annoying. Okay. It only uses a character pointer instead of a const character pointer. We don't really want to cast that away. Okay, so what we'll do is string length. We'll take library name, right? U32. Is U32, I think, right? Nope, it's U64. Right. We'll take that, and then we'll say K free. The block is going to be library name. Whoops. Name. And then size of character times length plus 1. Wrap these in parentheses because that's the total character count, accounting for the null character. Yeah, and then mem tag string. That's annoying. I should probably fix that at some point, but for now, that will have to do. So that should fix that one. What is this bleating about now? Oh. Makes me explicitly cast it to a void pointer. Also annoying. Okay. So I'm just going to copy this block for file name. All right. Now what is it bleating about? Oh, because I'm doing a string free here as well. So let's do this one more time. That is kind of a crappy API, I'm not going to lie. I need to fix that. But it's kind of outside the scope of what we're doing right now. Okay, so everything built successfully. However, to make sure that all of this works the way that we want, I'm going to put a breakpoint here, just so that we can kind of step through the code real quick and see how it all works. All right, so we're going to go ahead and load up the library. Oh, I should probably do this. You know what? I see a bug here already. I shouldn't keep the name or the file name until after I've confirmed that this works correctly. So let's take these two things, right? Because there's zero reason to do this ahead of time. And put it down there. All right. So we'll step into this. We'll step over these various memory functions. So our file name should be Vulkan renderer.dll, 0 terminated, so that's good. You know what? There's the possibility for a bug there because this is actually filled with garbage data. We should probably initialize that array first. That's going to be a nasty bug if we don't do that. So let me do that first. So we'll say K0 memory, file name, size of character times max path. Just 0 initialize that so we don't run into any problems with it. I'm going to set another breakpoint here just so we can skip past some of those lines. So yeah, file name should be all zeros now. Yeah, it is. Okay. So at this point, we do have just Vulkan underscore renderer.dll. So that works correctly. We see there that we loaded the symbols. So it looks like we have our Vulkan renderer DLL. Okay, it was loaded. So we have that. We'll go ahead and duplicate the name and the file name. Allocate a line before the memory system is initialized. Yeah, that's probably because we shouldn't be doing this here, but we'll move it later. All right, and then we'll create the functions. So that looks like it works as expected. The next thing we'll do is load the plugin create function. So that should be very much the same thing, get proc address. We did find the plugin create, so it found that function. Here is where we set up that function, and then we push that into the array. So that is good. We're going through our functions. String equals, that should be the first one, so it should immediately call this. So here's where we're invoking that function. So this should jump into our plugin create, and it does. So our dynamic loading is working as expected. So I'm going to go ahead and continue the application. Let it load up. Beautiful. We are up and running. So we are now dynamically loading up our renderer library, which is awesome because we don't have to now have any of that logic or code or types or any of that hard linked anywhere. So what this also means is if, for example, we had another plugin that we wanted to use here that was outside the context of Vulkan, right? Like, let's say, for example, that we wanted to use an OpenGL plugin or DirectX. It literally would be that to load one library versus the other. So if we had another renderer library that was called DirectX renderer, the only thing that we would have to change to go from one library to another is that string. That's it. It literally becomes that easy because we set things up in a way that is sort of render agnostic, and everything goes through an interface. That becomes a lot easier. So let's see, we're about an hour and 20 minutes into the stream. So I think what I'm going to do here is I am going to go ahead and I'm going to create a new branch. Well, actually, do I need to? Yep. Am I still on that feature branch? Yes, I am. I'm going to go ahead and commit this as is, since we're at a point where we're running. I think it's safe enough to go ahead and do this. Git commit Vulkan plugin dynamic library loading. and then git push. Oh, that's going to take forever because I didn't pull in main. I wonder how hard that's going to be to merge that in. I should have done this on a new branch, pulled off of main. Let's see. By the way, any ideas about game with Kohi Game Engine? You said you're going to do one this year. Yes, so I actually do have an idea. I'm not quite ready to reveal it, but yes, I do have an idea. It's going to be a relatively simple game since we don't have a lot of our utilities yet and we don't have a lot of features implemented. There are a couple more things that we're going to have to implement before we can get to that point. So things like level loading and unloading, we're just having the concept of a level slash scene slash whatever you want to call it. We need that. We also need audio because you can't really have a game without audio. So we need audio. So we're going to have to make an audio plugin. Let me think, what else? That might actually be the only couple things that we need. Realistically, there are some renderer improvements that we need to make. So we actually need to come up with something that where we can have multiple lights that aren't hard-coded. Because if you recall earlier in the series, we sort of hard-coded the lights that we have in place. So we actually need to fix that too. But none of those things are particularly huge. So I think what we're going to do is we're going to finish up this dynamic loading stuff and then probably jump back into rendering, and maybe the lighting stuff is the stuff we'll do next. Because we don't even really have to render using PBR or any of that stuff for a basic game. So yeah, probably lighting will be the next thing I fix, and then like a scene graph, loading, unloading, all that. And then the audio plugin is what I'm thinking. So scene, sound, improved lighting, game, that is a roadmap, more or less, yes. At least for, the early part of this year. So like I said, the game is not going to be like some huge thing. It's going to be a test case, essentially. But it is going to be, a fully playable game that we can, because that's also going to require. One more thing that I've thought of is right now everything that we're doing is debug builds. So we actually need to have the concept of a release build, as well as some way to package resources, which that last one we may or may not get to. But we do need to have the concept of release builds because we've got a whole bunch of stuff that is debug code that we would not necessarily want to run in a production build for performance reasons, like all of your Vulkan debug layers and stuff like that. All that stuff shouldn't be loaded in a release build. So release build is actually another thing we need to do, but that shouldn't be a huge deal. Okay, so I'm gonna try this merge here and see what we get. Actually, it's saying it can merge. Okay, so let me pull this down so you guys can actually see what I'm looking at. So what I was looking at was I just pushed this this branch up. I forgot to pull in main, so it looks like a lot of. Actually, it looks like it's figured out everything that we've added. No, it didn't. So it's got all this stuff in here too. That doesn't necessarily need to be there. So I'll fix that off camera, but we at least have it committed, so that's fine. All right. So let me think. We've got a little bit longer on the stream left for today. What can I tackle in that amount of time? I guess we can probably go ahead and start moving some of the game code, because I kind of wanted to do that too. Let's see. So in about plugins, everything that is not in the engine's core will eventually become a plugin, like the renderer, sound, console output. Yes, exactly. So that wasn't something that I initially planned for the engine, but the more I thought about it, the more I liked the idea. So yes, essentially everything that is not in the engine's core will become a plugin. And there are things that are in the engine's core right now that will be a plugin as well. So console output is actually going to be a plugin. And the beauty of that is when we do that for release builds, we can just not include that plugin. And then we automatically just disable console output for release builds. So yes, that's correct. Okay, so I guess let's start moving some game code around, because the other thing that I want to do is demonstrate the hot reloading, but I can't do that without something that's actually hot reloadable. And there's still a little bit more work that would need to be done in the Vulkan renderer to hot reload it. So I don't think that's a good candidate. And I also think that's the case because hot reloading your renderer doesn't really make a whole heck of a lot of sense. There's not a whole lot that you would want to change within the renderer that would make sense to hot reload, because a lot of it is going to be stuff that's already uploaded to the GPU that you wouldn't really want to change afterwards. But it is hot reloadable now. So with that, let's go ahead and create a new project here. So we have a testbed, and what we're going to do is all of this stuff that is specific logic to the testbed itself, outside of all this setup code towards the bottom, right? So all of this configure the render views and all that stuff, like this stuff I'll leave here, but anything that is sort of game logic, so anything within this render loop, for example, or this game update loop, all of this stuff is a prime example of something that we could split out into a hot reloadable library. And then we can change this logic and on the fly sort of see the results of it. So I think we'll go ahead and set up one of those now. So to do this, let me collapse some of these folders here. And I think I'm going to have to go down here to the bottom. And I'm going to call this testbed underscore lib, I guess, or library, lib. I'll go with that. Oops, I created that as a file. I don't want to do that. That should be a directory, not a file. New folder. Testbed lib. All right. So just like our other stuff here, we're going to have a source folder within that. And basically what we're going to wind up doing is, I think I'm just going to move a little bit of the logic for now, just to sort of get the idea across. So let's do a new file, and we'll call this testbed main.h and testbed main.c. And the other thing is we're going to define some of our types in let me think about this for a second. So we should probably define some of the types for our functions within the engine itself. And what I mean by that is, what I'm thinking about is if we go into our testbed, specifically in our game, and we look at our game update, this is sort of a standard function that we're going to call all the time. And this is actually part of our update, right? Like we actually make this assignment here, right, as part of our out application. And so our application itself has these function pointer types. And what we could do is remove it from that level and remove the assignment from here and do it somewhere else, pointing to different functions that we haven't actually loaded up yet. But I'm not 100% sure that I want to do it that way. I'm thinking I might just have another layer of update and render functions that we manage within the game itself for now. So I think I'm going to do it that way just to keep from breaking this. Let's see. How programming in your game engine will look like for a user. Will there be multiple C files with the update and start methods? Their logic will be defined or something else. So I think what you're asking is basically what I'm trying to figure out right now. So what I'm really looking for is we basically want to have in our game codes library a couple of exported functions for like maybe like a boot or an update, a render, those kind of functions. That all we have to do is define them at this level and then tell the game to say, hey, load this library and point to those functions, and then it just does the thing. And so that's what we're more or less going to set up now. So let me see real quick. I just want to check. Yeah, all right. So let's go ahead and start setting this up. So what I'm going to do is I'm going to copy the definitions from here. So we have our update, our render. I guess we could take these, right? We'll implement these. So right here. Oops. So we'll take these, move them over here. What do we want to call these? I don't know if I want to call it game. Let's call this application boot, right? We'll stick with this application sort of theming here. So we'll have application boot, application initialize, application updates, application render, application on resize, and application shutdown. And all of these, first off, we need to do pragma once and include defines.h. All of these need to be exported, right? So these are the functions that we're essentially going to load from our executable that are going to be hot reloadable. Why is this bleating? Incompatible. With what? Oh, probably because I don't have these other types. So, what do we need? We need probably these application types for one thing. Render packet, that's probably going to need do we not have actually, you know what, I could probably just forward declare that. Oh, I am forward declaring it, so we'll say struct render packet. Actually, I don't even need, I could just do that all the way down. Let's just do that. So struct application. Right, and then I can just put that in here so we don't have to include all that because that's kind of dumb. We'll get the F32 from defines. Same with the U32s. All right, so that should actually... So this is going to be our interface, right? This is going to be our hot reloadable game code interface. And so we're probably going to wind up taking several passes at this, but that's fine. And what I'll do is go into testbed main. First off, include testbed main h, and we'll go ahead and delete those. And for right now, these are going to be just kind of dummy functions. And we'll move bit by bit logic in here. So essentially what we're going to do is we're going to get the procedure address for all of these. So I'm just going to stub these out. Return true, return true, return true, and return true. And these don't need to do anything, okay? We need to set up in our build script a new library. So right after we have testbed, I'm going to copy this Vulkan render lib. And before we make... Should I do this before or after the testbed? I guess it doesn't really matter. Testbed lib. Okay, the target, or the assembly rather, is going to be testbed lib. We'll leave the versioning alone for right now. It does need the engine. It does not need the Vulkan SDK. It does not need any of the Vulkan stuff at all, actually. So all we're linking with for the user library, if you will, is just the engine for now. And that actually should be all that's required. I'm going to go ahead and just, for the sake of argument, I'm going to do the same thing in the bash script. So testbed lib. I actually don't need this bit. Vulkan render, this is going to be, whoops, testbed lib. We just need the engine. We just need the engine. Okay. Oh, that reminds me. The testbed itself does not need to link with the Vulkan library at all either in the bash script. So I figure that script should probably be updated as well. All right. So that's the build for that. Let me just build this and see if it builds properly. We should get a testbed lib DLL here. So we did build that correctly. So I guess the next thing to do is going to be in the actual game itself this time. Actually, you know what? I could move a lot of this over now and just change these function pointers. Should I do that? I think I will. I was going to put this off, but I think I'm just going to do it the right way. Maybe a game jam using your engine. When you implement scenes, etc. Yeah. I think that is going to be definitely something I want to do. I don't know that the engine is going to be far enough along anytime soon to do that, but I know once we start implementing an editor, that's definitely something I want to do, for sure, 100%. Okay. So we want to dynamically load the game library. Right, so, and then we're going to assign function pointers, just trying to map out what we're going to do. So instead of these things pointing to hard-coded functions here, we're going to be pointing to our loaded function pointers. So in this case, we're actually going to take a copy of this. And we are going to just plop that right here. This is going to be testbed lib. And right now that's saying render library. That's wrong. So we need another dynamic library. Put it down here. And we're going to call this game library. And obviously we do need a better place to store this, but for right now I'm okay with putting it there. So game library, which means this is going to be, whoops, did I seriously leave the Y off of that? No, I didn't. Didn't copy it for some reason. Okay. Application has no field. Yes, it does. I'm looking at it, you dingus. What are you talking about? I can literally go right to it. All right, I guess IntelliSense is tripping. Whatever. Okay, so what we're going to do is dynamically load these functions, right? So this is application underscore boot initialize blah, blah, blah. So we're going to basically do this a bunch of times. So the first one is going to be application underscore boot. And then that's going to be game library. And we're basically just going to call this a bunch of times. Right. So we have boot initialize update render on resize and shut down. Right. So we're going to dynamically load up our function pointers from the loaded library. And then instead of doing it this way, we know the order that we're loading these things in, right? So we could literally, instead of having to loop through these, we can say out application render library functions sub 0, right? And then this is basically going to be just cast to this, which is going to be super ugly syntactically. Why did it give me this? This should be application. Why did it give me that? Right? Is that gonna accept that? Let me get rid of this. So what I'm basically going to do is just use the array entries themselves. I don't know if it's going to let me do this. Syntax is probably going to throw up. Yeah, it's reading that as... It doesn't know what the heck that is. Okay. Probably the easiest way to do it with the typecasting here is just going to be to type def it, as I did up here. So type def pfn application boot. So we'll just cast it to that. That's probably going to be the easiest way to work with it. Let's just build this real quick. Oh, because I didn't use pfn. Yeah, that built successfully. Okay. I don't know why. Why is this still? Let me reload. Okay, I guess my IntelliSense was just freaking out for a second. I wonder if I could just do this. Does it need that typecast? No, it doesn't. Okay. All right, so the easiest way to do this is just going to be to go by index, which if I ever change the order that I load these things in, I'm going to be screwed. But this is just for the sake of expediency and getting this to work. That's what I'm going to do. So what that means is in the testbed main, I basically just have to fill this out with all the code that is currently in the game, which I hadn't planned on moving all this over, but I guess now is as good a time as any. So I'm going to copy this out of game.c, and I guess I'll just move the code around in here. So I'll put this down here. This is a private function, I believe. So that one can stay. Game on resize. Okay, so I can take code out of this. Application on resize. Put that there. I can take, let's see, this. Game on event, I need to keep that. Debug on event, need to keep that. Game on key, I'll keep that. Let me take all this stuff and move it above this where it was in the old game file. The game boot, take all this out. Slam it in here somewhere. Where is it? Game boot is now application boot, which is a little bit more it's a little bit more consistent with our naming convention otherwise. Game initialize. Once again, we'll just come up here. Where is application initialize? Right there. Game shutdown is going to be application shutdown, which I think is at the bottom of this list. Game updates. So this is the code that is going to benefit the most from hot reloading. So we'll clip that out of there. And we will, where is it? Application updates, put that in here. And render, which I think is the last one we have to actually contend with right now. Is render, application render. All right. And I guess I need to move all these includes to the top as well. So take that except for this one and that all the way to the top and slam those in there. Probably would have been easier just to copy over the file and rename the functions, but it is what it is. Okay, so debug console, game commands, game keybinds, this stuff can all actually be moved over as well. So take these and move these over to our testbed lib source. And then our entry, let's see, it's using game.h, but I don't actually think we need what is left in game.h. So we actually don't need any of these guys anymore. Game.c, I don't think we need it at all anymore either. No, we don't. So So let's see, the game state. Does the entry need to know about the game state? It does for here. So that might be the only thing that gets a little bit tricky. But let's remove game C, because we don't need that anymore. Let me just build this real quick. This is probably going to fail because of game H not existing. So game commands. Why does this need game H? I don't think it does. Yeah, I don't see any reason that this actually needs that include. Game commands, let's see. Application is unknown. Okay, so that is going to be, where's application defined again? So that's going to be application types, which is in the engine. So we can just include where was that again? Just application types, okay. So that should fix that one. Okay. Game keybinds. Again, this only really cares about the application, which this is an H file, so actually we need pragma once. That wasn't there. And then we need to struct application. And then we can just throw a struct in here, and that's for declared. So that simplifies that a little bit. In fact, did we do the same thing for game commands? Yeah, we can do the same thing for game commands. Let's copy this. Get rid of all these game.h requirements. Game keybinds. So this needs a bunch of things, but it's going to need game keybinds. Does this actually have defines? This does not have defines. Include defines.h. That's missing all kinds of stuff. Let's see. Keys. So don't we have inputs? How do we not have input? That's interesting. Include. I don't think it was just input.h. I think it was core input.h. We really didn't have that. That's surprising. Okay. I guess it's going to have to also be include core keymap.h. And we need include core, oops, I think it's just application types .h. Okay. Now what are we missing? Game state. Okay, so the game state bit is going to be a little bit of a challenge. Right now our testbed is basically just like an empty application, right? And so what we could do is we could essentially add a new interface function that we could call to get us the size of the game state as defined by the application, which is probably the way we're going to go. That way we can move this game state. So actually, yeah, I'm going to move this now. And I'm going to rename it game state H. And then an entry C, I think the only thing we're going to be missing is this guy. Right, so we'll need to include game state.h. That fixes the errors there. This needs to have a struct in front of it. Then this is going to have to, actually that doesn't have to include anything else, that should be fine. I don't know why that's still bleating, but okay, that should be fine. We need to include that here as well, so include game state.h. Okay, so that's all of that. No rule to make targets entries. Okay, all right, so that's going to be, we're going to have to clean and rebuild to actually get this to all show up correctly. So this is actually including a game.h, which is wrong. Okay. So let's just reuse this real quick. I'm going to say U64 pfn application state size, and this is going to take nothing. We're going to include in testbed main another KAPI function, U64 application state size. And in this, in the C file, right here, we'll go ahead and define it, and we're just going to return size of, and we'll use game state. Why is that bleating? Type, oh, size of game state. There we go. Okay. So now in entry.c, we can come here and load up one more function. And we'll just keep this one locally. So we'll say application state size, get state size. We'll default that to 0. And then the first function we'll load is going to be this application state size. We'll load it from here. That's going to offset our indices here, which is fine. So let's just update this. 5. Okay. And then we're going to set this to actually, before we do that, so we're going to need to, after we load this, we're going to set get state size equal to the first function that we load, right? And then here we can set this to get state size. And let's see, 1, 2, 3, 4, 5, 6. That should give us everything that we need. I believe that is it. So I'm going to clean and rebuild. Oh, I just spotted a bug actually before I even run this. This is the danger of copy pasta. We have our, this is pointing to the renderer library, which is wrong. That should be game library. And that's going to be true for all these guys too. Right. And while we're at it, why don't we just kind of remove this because it kind of sucks. So why don't we just say plugin create. We'll initialize that to 0. Actually, we don't even have to do that because that's going to be done here. So actually, we can just say the renderer library functions sub0 dot pfn, and then we can just call plugin create and pass that. And that's, yeah, we'll have to wrap that in a negative check. Return false. Right, that's a lot cleaner than this. Okay. So create the renderer plugin. And from there, we should be good. Did I clean already? I think I did. Testbed lib is in there, so let's go ahead and build. Should be interesting to see if this runs the first time or not. All right, let's go ahead and I'm not going to set any breakpoints. I'm just going to do it live and run. Oh, what do you know? It ran on the first shot. So that's pretty awesome. And so just to demonstrate that this actually is working the way that we anticipate, in the testbed main, I'm going to set a breakpoint in the update. So application update. I'll put it right here. Boop, we hit it. Means we have all the symbols loaded and all that stuff. So now our game code is also separated out into a library of its own, which means that next time we can actually look into hot reloading of said game library. So that is where I'm going to wrap this stream up, because it's like right pretty much on the dot at 2 hours. So I'm pretty satisfied with that. Pretty satisfied with the progress in this stream. Do any of you guys have any questions or comments before I wrap up? Just give you a minute to type that out here. And while you guys are doing that, if you are, if you didn't know this already, all of these videos are archived over on my YouTube channel. So that is youtube.com/Travis Broman. And if you guys haven't already, give me a follow here. I would greatly appreciate it. As well as go ahead and check out my YouTube channel. Make sure to subscribe to that and hit the little bell there so that you get the notification as to when the new videos there drop. I do archive all of these stream videos there, and I will also be on occasion making videos on other topics there as well. And yeah, I think that does it. You know, make sure to follow me everywhere else, like Twitter and whatnot, just to keep up to date on what I'm doing with this project. So I'm going to go ahead and get this checked in. So get status. And I believe we are still on the Vulkan static removal branch, which is probably the wrong branch to be doing this, but moved game code to lib. And all right. So we already had, I thought we had here a pull request. Did I not? Yeah, I think this is it. Let me just merge that into main. All right. And let's see. Files changed 30. Yeah, that's not too much of a surprise. I guess the main thing I want to check real quick. Wait a minute. What do we have? Okay. Yeah, I think we're gonna be good. Alrighty. Let me go ahead and get this. Oops. Wrong button. So we already have that. Let's merge it. Squash and merge. All right. Now, before I forget, switch back to main. Anyway, so that is going to do it for this stream. So thank you guys so much for following along. I really appreciate it. And yeah, I'll catch you guys on the next Wednesday stream, Wednesday at 9 p.m. It's typically when I stream. That's my official schedule anyway. And yeah, I'm just going to run this one more time and then we'll cut things off. So yep, looks like we're still running. Yep, okay, we're good, cool. I will see you guys next time. Thanks so much.